Oh, these are just very straightforward, guys. Remember, logs undo exponentials, exponentials undo logs. So, base 3, log to the base 3 of x squared is what? X squared. You guys got it. Some of you over here got it. Some of you over here got it. Back there as well. It's x squared. Base 3 and log to the base 3 cancel out. Guys, they're inverses of each other. So you got x squared. True. Well, log to the base 5 of base 5 of 10. What happens here? Base 5 and log to the base 5 undo each other. So we get 10. E and ln undo each other, right? So they undo each other, so we get 2. So remember that you should be able to see those very quickly. Very good. Most of you got it. Awesome. Let's get going on what we're doing today. You're going to want to have a place to take some notes. So let's see at the back of the worksheet. Yep, I have some blank space. Also, don't forget to hand in what's due today, but hand that in a little bit. So we're going to review, so you can just watch. Let's review what we learned last time. We're going to use that again, some of that stuff again today. So if I said to you, rewrite this as a log, I want you to take a whiteboard and try it. Show me that you can still remember what we learned last time. Take this exponential statement. It's a true statement. 3 squared is 9, yes. This is an exponential form. Put it in logarithmic form, which is an equal, the inverse form. It's equal in value, just different form. For those who got it, we need, this is base 3 to the second power. I can't quite tell. Base 3 to the second power equals 9. What's my base? 3. What does base 3? Log to the base 3. So we're going to log to the base 3 of both sides of the equation. Log to the base 3 and base 3 cancel out, right? We get 2 is equal to log to the base 3 of 9. Good job to those of you who got it. Okay, do this one. Erase your whiteboard. Find a marker that works so I can see. And then rewrite this logarithm in its exponential form. So it's equal form, but is an exponential. Good. Good. We could have the light on right now, and it would be good. I know it's heaven. So we need to undo log to the base 2. So we base 2 both sides of the equation. Base 2, log to the base 2 cancel out. So 8 is now by itself. 8 is equal to 2 to the third power, which should be a true statement, and it is. We're all good. Okay, good. Just making sure you remember what we learned last time. Okay, what I want you to do is, as a group, like talk to each other, I want you to remember what we learned last time and simplify this 2 different ways. Ready, go. Talk to each other, help each other out. So once again, we can simplify this by using either the change of base formula or rewriting it as an exponential and using our brains and thinking about it a little bit. Either works. So you're doing 11 through 16 and 21. What we would do is just, our final answer is this equals -3. Okay, so that would be our final answer, -3. Way to go. Okay, awesome, good, we got it. So don't forget that. Okay, so now we're going to get started on today's lesson, a huge important lesson. So today we're doing 8-4, which is properties of logarithms. You've got to pay close attention, and really these just come from practicing a lot. I really wish I had a bunch of free calculus books, because we just learned this in secondary 3 honors, and they just have so many great examples in there. So I'm doing the best here, but I might throw on some extra examples that we just need to practice, because there's just so many good ones. So recall that we know that logs and exponentials are inverses of each other. For example, log to the base 3 of x is inverse would be base 3 to the x, right? Base 3, log to base 3 that. Okay, so as a group, I want you to remember back to like the first lesson of the year, which was properties of exponents. And remember we had a little song. When you multiply the same base, you add. When you multiply, you add. When you divide, then you subtract. Raise a power to a power, and you multiply. Okay, so what I want you to do is, as a group, go through and simplify 1, 2, and 3. Notice they're the same base. We do not change the base, right? You're not going to double dip and say 4. Not how properties of exponents work. The base doesn't change. When you multiply, you add. So tell me what these would simplify to be. Ready, go. As a group, talk. See if you can figure it out. Go, go, go. Maybe write it down on the whiteboard. We know when you have the same base, when you multiply, you add. So this simplified to be base 2 to the x plus 1. I saw most of you not make the tragic mistake of multiplying the bases. That's not how this works. And then when you divide, then you subtract. So it'd still be base 2. And then it's always the top minus the bottom. X minus 1, right? Very good. And then right here, base 2 raised to the x raised the power to a power, and you multiply the powers. The base stays the same, so that'd be 2x. Very good. So those go hand in hand with properties of logarithms. Now, why is that true? Because remember, you can take an exponential and rewrite it as a log. You can take a log and rewrite it as an exponential. So if we know properties of exponents, we know properties of logarithms. You're going to want to write these properties of logarithms at least somewhere on the back of your worksheet or something. So this is the product property for logs, which this should be really easy for us to remember because we already know properties of exponents. When you multiply, you add. Do you see how when you multiply, you add? So if we have log to the base b of a plus log to the base b of c, because they're both base b's, log to the base b's, when you add, you can actually rewrite this as log the base b of a times c. So it's kind of going backwards a little bit. We can go back and forth. Like we're literally going to be switching back and forth between these two forms. So does everybody see how when you multiply, you can split it up and rewrite it as 2 logs with addition? When you multiply, you add. Do you see how it's the same thing, everybody? Yes or no? Okay. That's called the product property. Make sure you write down what it's called because I'm going to ask you which property is being used. So, and once again, so if you see that you have addition, you could put this into one single logarithm, which is actually more important, taking 2 logs that are split apart and putting it into one logarithm. So because they're adding and they're both log to the base b, you can put it as 1 log to the base b with a times c. All right, moving on to the quotient property. When you divide, then you subtract. So it goes hand in hand. Log to the base b of a minus log to the base b of c can be written as 1 logarithm, log to the base b, because they're both base b, of a divided by c. So notice it's the top, subtract the bottom, just like before, right? With properties of exponents, you see how it's the top, subtract the bottom. Okay. So what subtraction does is it flips it and puts it underneath here. On the bottom of my fraction. That's called the quotient property. Quotient means division. And so if you see something like this, log the base b of a divided by c, you could say, oh, I could write that as 2 separate logarithms and split it apart. That'll be log the base b of a. Because of divide, we subtract log the base b of c. And moving on to our power property, this one's it's similar, but it just sounds a little different. So we have log, it's called a power property because we have log to the base b of a raised to the c. When you raise something to a power, then you multiply the power. So what we're doing is we're taking the power, c, and we're multiplying it out in front. So you're multiplying it to the entire log. So let's raise something to a power and you multiply. Because you take the power and multiply it in front instead of having it as a power. So if we were to go backwards, if we saw this, c log to the base b of a, since c is multiplied in front, before it used to be a power, so we put it back up here. So we're going to be switching literally back and forth between these two things, and we have to be able to determine what's equal. So properties of logs are the exact same as properties of exponents. Everybody have those written down so we can start practicing. Okay, they just come with practice. So here we go. Number 1 on the worksheet. The instructions are condense the logarithm, kind of hidden, condense the logarithm. So that means, look, we have 2 separate logarithms. What our goal is to rewrite this as 1 logarithm. Now your question is, can you rewrite this as 1 logarithm? This is base 10, oops. This is base 10, and this is base 10. So they're the same base, right? So we can put these together. So our goal is to rewrite this as 1 logarithm. So what your first thing you're going to do is you're going to take the powers, because look, 6 is multiplied in front, 3 is multiplied in front. If you have something multiplied to your log, it's actually an exponent. So we're going to put that up there, and we're going to take this and put it up here, not with the sign. So let's rewrite this. Log to the base 10 you should try to show your work of 8 to the 6th power. So we're really looking at this. Plus log to the base 10 of 5 to the 3rd power. Does everybody see how I rewrote it? And now we can put it, we fix the powers, now we can put it as a single logarithm to the base 10. This time I'm not going to write base 10 because we know we don't need to write base 10. So we have one logarithm. Now we're going to put parentheses because we're rewriting this as one logarithm. When you multiply, you add. So when you add, you multiply. So this will be 8 to the 6th times 5 to the 3rd. And now we've taken and written this as one logarithm. We have one log, the base 10 of all that stuff. That's why I want to see your work. I want to see you write it out. Now notice, let's all take our calculator and let's simplify it. So 8 to the 6th times 5 to the 3rd. It's a huge number. So I would want to see this, and then also I want to see if reasonable, if it's reasonable. So that simplified inside to be 3, 2, 7, 6, 8, 1, 2, 3. But I really would rather see this, because then I know you knew the properties of loss. But you guys get that we could go that far. And now we're done. We've put this into one logarithm. Pretty easy, right? Just getting it in practice. Let's do another one. Any questions? Let's do another one. Number 2. So the first thing you've got to do is say, do I have the same base here? Log to the base 6, log to the base 6, log to the base 6. Yes. Now the first thing you've got to do is fix your powers. Now anything multiplied used to be a power. So let's take the 4 and put it back up here where it should have been. So we really have log to the base 6 of 3, if we want to get technical, put parentheses, log to the base 6 of 7, plus log to the base 6 of 8 to the 4th. Now when you multiply, you add. So when you add, you multiply. Because they're all log to the base 6, we can rewrite it as one log to the base 6, and I want parentheses. So it's addition and addition. So all this stuff is being multiplied. So we have 3 times 7 times 8 to the 4th. That would be the answer I would want to see. And now if it's reasonable, you could rewrite it as well, times 8 to the 4th. So this is really log the base 6 of 8, 6, 0, 1, 6. I want to see both answers. You see what we did there? Yes.
So you don't want to like both or log?
No, and we could if I asked you to do that. So that's actually the point of this. Good question. Lydia asks a good question. So now we would know that we can use change of base formula to solve this. So that's really the ultimate goal here, is to be able to get to that point. So yeah, you're already seeing ahead of time what the goal of this is. Okay, so number 3, here we go. This was the first time we say subtract. But this is very important. You always need to fix your powers first. So look, we have log to the base 6, log to the base 6. So you'd say, okay, I can put this into one logarithm because they're both base 6. But first, anything multiplied in front is actually an exponent. So you'll take the 3 up, ding ding, you'll take the 4 up. You will not take the negative with it though. So we're going to rewrite this. We have log to the base 6 of 2 to the 3rd power. That piece became 2 to the 3rd, right? Minus log to the base 6 of 3 to the 4th power. So when you divide and you subtract, you always subtract the top from the bottom, which this one came first, so it's on top. So now our goal is to be able to write it as one logarithm. So we have log to the base 6 of, I need parentheses, what goes on top? 2 to the 3rd. When you divide, then you subtract. So when you subtract, then you divide. So 2 to the 3rd divided by 3 to the 4th. That is a beautiful answer. I need to see that one. And then also 2 to the 3rd is 8, right? 2 to the 3rd is 8 over 3 to the 4th. Yep. And that's good. Both are great. I would like to see both, yes, for this at this time. Okay, let's do number 4. Notice 54 does not have a logarithm. Yes. Perfect. There should be a 3. We got to add that in there. So on 4, we have 54 minus 3 log to the base 2 of 11. Now here's what people tend to do. They think that we can take and when you subtract, you divide and all of this stuff, but no, that's not true unless you're combining your logarithms. Is there a logarithm here? No. So there's nothing we can do with this. This is literally 54 minus log to the base 2 of 11 to the third power. So we could bring the 3 up. So we would write 54 minus log to the base 2 of, we did bring the 3 up because that's a power, and then 11 to the third, which is 1331. And then there's nothing more we can do with that. Now we could actually simplify that because we could type this in with our calculator, change our base formula, we would do 54 minus that, but we don't need to. Like, we're just going this far. Okay, number 19. So flip to 19. 19n in particular. So let's combine this, condense it into one logarithm. Notice they're all log to the base 10. Now what I want you to notice is there's parentheses here, kind of here to trick you. Because with subtraction and addition, the parentheses here would matter if there was like a negative out here, but there's not, correct? So let's just rewrite this because we don't need to do anything. There's nothing that changes here, and subtraction is, this is just addition and subtraction. So we have log to the base 3 of what is that? I must be missing something. Oh, it's log of 3. No wonder. I was like, what the? Okay, log of 3. There we go. So we're rewriting this. Log of 3. So let's put parentheses. Minus log of 4, because that's technically what we're looking at, minus log of 2. So now when you subtract, then you divide. But if it's not subtraction, it does not divide. It stays on top. So do you see how this one's positive? So we're going to have one log. We can put them all into the same log. We're going to put our parentheses. 3 goes on top. Now it's minus, so we're going to put the 4 on bottom, because when you subtract, then you divide. And now look, minus 2. So that minus just takes the 2 to the bottom as well. So if there's 2 minuses, any minus just puts it on the bottom. Everybody sees. So that's what we would do. You know what I mean? So if there's multiple addition ones, they're just on top being multiplied. And if there's multiple subtraction ones, they're just on bottom being multiplied. So we would show our work as such. I'd want to see that answer, and then I'd also want to see 3 over 8. Four times 2 is 8. Let's do 19s. So notice in this one, there's a lot to do. So paying attention on this one, 19s. Notice they're all log to the base 10 again. And then I want you to notice something else. We have a 1/2 power. We have a 1/2 being multiplied, a 1/3 being multiplied, and a 2 being multiplied. That's the first thing you've got to fix. That is absolutely the first thing you've got to fix. We know that if you have a multiplication in front of a log, it's really an exponent. So we're going to take and show our work and rewrite this, which I know there's not a lot of room, so you might want to do some of this on a separate sheet of paper, because it gets messy other way. So we have log of, let's use parentheses, x to the 1/2 plus log of, parentheses, y to the 1/3 minus log of z squared. So I'm showing my work. Now I've fixed the powers. So now from here I'd say, okay, I can combine these using properties of logs. When you multiply, when you add, or when you add, you multiply. When you divide, then you subtract, or when you subtract, then you divide. So because they're all base 10, we can write it as one log. We're going to use our parentheses. X to the 1/2 goes on top, because it's positive. Now it's plus, so this also is going to be multiplied on top. And now we're subtracting z squared, or log to base 10 of z squared. So when you subtract, then you divide. So that z squared is going to come on bottom. Now what I want you to do is say, I know if I have fractional exponents, rational exponents, they're secretly radicals. Not so secret though. So the last step would be to take those fractional exponents and rewrite them as a radical. So we have log of the square root of x. Isn't that what this means? And then times the cube root of y to the first I just rewrote that. Divided by z squared. That is just z squared. This would be my final answer. So any fractional exponents, oops, don't look. Any fractional exponents you'll want to rewrite as your final thing as this. Okay. Everybody good? Do you feel like you could do the rest by yourself? Yep, go for 19. Go at it. Ready, go. Okay, here we go. Number 28. So guys, notice there's just one logarithm, and they're kind of bad at putting parentheses, and I like parentheses. So what I'm going to do is put on parentheses. We're really looking at this. Log of x, y, z, all of that. So now notice there's only one log. Now notice there's 3 different bases. So we're going to go backwards and split this apart. Expand the logarithm. So rewriting it as many logs. Now when you multiply, you add. So this is the same thing as log of x. I need to see your parentheses. Plus, because it's multiplying, log of y. Because it's multiplying, it's another plus log of z. And we're done. We've expanded the logarithm. So it's just going backwards. Look at 20b. Once again, they're really bad at parentheses. Throw them on there. It kind of helps us see it better. Log to the base 2. What? Yeah, we're just expanding it. So, because once again, this is just one logarithm, but it's really multiple logs spread apart. So, notice, couple things here. We're doing log to the base 2, so we're going to split this up into a bunch of log to the base 2's, and notice there's an x, a y, and a z. There's going to be 3 different things, correct? Yep, so it's add, because this one's on top, so we're going to have log to the base 2 of x, and then it's going to be subtract, because look, y is on bottom, log to the base 2 of y. Now look, z is on bottom, so we also need to subtract log to the base 2 of z. Because remember, subtraction just means it's on bottom. That easy. We're done. What? Ooh, yeah, it's so cool. How about C? Now let me show you a common mistake that I know you're not going to make. Once again, there's parentheses here. I like to have those, so I'm going to put them on. People will go, oh, 6 is connected to x cubed. But haven't we talked so much about how they're not connected? That's 6 times x cubed. They are not connected. 6 is its own base. So we have a bunch of multiplication here. So when you multiply, you add. So we're going to have log of 6. 6 is its own base. Plus log of x cubed. Plus, because it's multiplying every time, plus log of y. Now we're not done, because notice one of these has an exponent still. Boom. That needs to be fixed. Right? That's what's being multiplied in front. So this would be our final answer. Log of 6 plus 3, log of x, I want parentheses, plus log of y. And we're done, because we have no exponents and everything's expanded. Pretty easy, right? Good. Okay, we're almost there. I just want you to look. This one's not on your worksheet. I'm going to go through this one with you. Log the base 2 of that divided by that. So when you divide, then you subtract, right? So this would be log the base 2 of the square root of x, like this, minus log the base 2 of the cube root of y. Now this would not be done, because technically we're looking at this. Log the base 2 of x to the 1/2 minus log to the base 2 of y to the 1/3. Are we still not done? Nope. Bring it down. Boom, boom. Bring it down. Boom, boom. And we're done, because I'm getting lazy. That's it, though. Okay. Okay, number 20B. Now my question for you is where is the parentheses here? Well, it's technically like this, isn't it? Okay, is 7 connected to the x minus 2 squared? No, and then I have a question for you. Is this connected? 3x minus 2. Yeah, it is connected. Good answer. I'm so glad you said that. Hey, look, what's being multiplied? Yes. Yes, because it's in parentheses. Yes, yes. So here's what people will do. They'll kind of get their properties mixed up and say, oh, I can just split 3x up and subtract 2. You guys get that? You can only split apart from multiplication and division, right? Okay, so let's split this up. 20b, we would have log of 7 plus, because when you multiply, you add, log of 3x minus 2 squared squared, right? Like this. Now from there you'd say, can I simplify any of those any further? Log of 7, no. But we have an exponent here, so that's going to come down in front. So we're going to have plus 2 log of 3x minus 2. Now, would it be appropriate to split up 3x minus 2? No. Good answer. It would not. You can only split up from multiplication and division. That's it. That's all we can do. We're done. All right. Okay, one more, 20e. I'm going to think this will be my last one. So we have log of, technically, I like to turn my parentheses of all this stuff. Notice the square root is around all of it, so let's rewrite this. This is log of 2rst divided by 5w, all to the 1/2 power, right? Square root means 1/2 power. So what we're going to do is the easiest way to think of this is to rewrite it. We're going to rewrite it as log of 2 isn't every single base raised to the 1/2 power. So we're going to rewrite it. So that would be 2 to the 1/2, r to the 1/2, t to the 1/2, divided by 5 to the 1/2, and I forgot an s to the 1/2, and multiplication doesn't matter, so we can reorder it. And then w to the 1/2. So now we're going to split this one up. This is why you're going to want your notebook. All of those are their own bases. So if you multiply, you add. So all that stuff on top is going to be added. So we have log of 2 to the 1/2 plus log of, and I could write it like this, r to the 1/2. This and this are the same thing. Everybody okay with that? Nobody confused? I put the 1/2 out of the parentheses and in, same thing, right? And then plus log of t to the 1/2, because it's on top, plus log of s to the 1/2. All of a sudden we're dividing, so now we've got to subtract, minus log of 5 to the 1/2. Now w is on bottom, so we've got to subtract, minus log of w to the 1/2. Now our last step would be taking all those exponents and putting them out front. Ding, 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 and so we would have 1/2 log of 2 plus 1/2 log of r plus 1/2 log of t plus 1/2 log of s minus 1/2 log of 5 minus 1/2 log of w. That would be our final answer. Yeah, it didn't really fit. You had to kind of chunk it up. Hey. So you guys are good with this one then? Let's have you finish. Okay. All right. So what I want you to do is 5 through 8. Finish up, wait, which problem were we on just really? 5 seconds ago? Finish up 20 and 5 through 8. Ready, set, go. Last little bit. So it says use properties of logs to evaluate the expression. To be able to evaluate the expression, we can do it 2 different ways. We can either individually figure out what that is, and then subtract it, or we can do it the easy way. Let's combine this into one logarithm using properties of logs. Isn't this log of the base 2 of, when you divide them, you subtract, so because they're both base 2, we can make it 1 log. So log of the base 2 of 8 divided by 4, which is log to the base 2 of 2, which is 1, right? Because we divide, we subtract. So we wrote it as 1 log, which is this, and then log to the base 2 of 2. This is technically log to the base 2 of 2 to the first, isn't it? Yeah. Don't log to the base 2 and base 2 cancel out, so we get 1. Or we could have used change your base formula, guys. Log of 2 divided by log of 2. Because don't you do log of this divided by log of that? Which is 1, right? Anything divided by itself? That means go that way, yeah. Evaluate, well, the reason they don't say solve is because there's no equal sign. Right. So yes, we are technically solving it, but what you mean by that is you're simplifying it, yes. Evaluating it all the way to the answer. So you're finishing the worksheet. Every problem is due next time.